Welcome to the Basic Laboratory Techniques workshop. I would like to ask you to stop me anytime you have a question. You can raise your hand or unmute yourself, and don't hesitate to ask questions. These workshops are to support the students, to make sure that when the time comes to do the quiz and the report of each experiment, the students know what to do and where to go if they have questions. So today is the experiment number 1 in lab flow. Basic laboratory techniques. All this experiment is about measuring with the correct number of significant figures and make calculations with those measurements. So we will learn in this workshop how to make measurements correctly with the accurate number of sig figs and how to apply those measurements in calculations. So I will give you a quick overview of the experiment. We will go over the write-up of the experiment. Then I will provide a few simple practice problems that will be helpful for you when the time comes to solve the quiz. And towards the end, I will make sure I go over the steps that you need to learn to complete the report. You're welcome. So here in the introduction, when you read the introduction in the first experiment, I highlighted what I consider is the most important, that when you are in a laboratory, it is very important to make measurements correctly. If you don't do the measurements correctly, you won't have accurate data, and all the conclusions might not be correct. So that's why the first experiment is focusing on the ability to use the correct instrument depending on the needs, to learn how to pick the instruments. If you have to measure length, which kind of ruler or measurement device you are going to pick according to the accuracy of the measurement that you need. And we know by now that each measurement will have an error. By now we know 2 measurements cannot be the same. No matter how accurate is our instrument, it will have an error. So if we are using a digital instrument, here I marked digital display. Let me put it here. Digital display. If you're using a digital balance, you must record every digit on the display. But if you are not using a digital instrument, let's say you are using a glassware or a ruler or a thermometer, you must record all the digits using the markings plus one further digit, which is estimated by you. So we will go over and we'll do some practice on that. So this is very important, how to read a measurement device and how to report a measurement with the correct number of significant figures. So then it's talking about in the write-up that it's important to be as accurate and precise as possible. And here it gives us a little explanation. What is accuracy? It's a measure of how close an experimental measurement is to the accepted value. If you know the density of water is 1 and you calculated the density of the water in the laboratory and you obtain a value that is 0.8 and another person obtained another value that is 0.9, 0.9 is closer to the accepted value, so it will be more accurate. And then the precision refers on how close repeated measurements using the same device are to each other. So basically, there are two different concepts. One is the accuracy. If this is the accepted value, and you have a value far from the accepted value, or you have another value that is close, the value in green is going to be more accurate than the value in red. But when they are talking about precision, they are talking about how close one value is next to the other. Let's say if I do 5 measurements, 1, 2, 3, 4, 5, and the 5 measurements are here but are close to each other. So that is precision. It's not talking about how close it is to the accepted value. So here, what it's saying, it refers to how close repeated measurements using the same device are to each other. So this is the difference between accuracy and precision. Let's continue with the write-up of this experiment. Let me go back here, down. Okay, so now we said at the beginning that this experiment is the number 1 is all about learning how to measure. It's all about measuring with the correct number of sig figs and make calculations. So they start with measuring length. When you are measuring length, we know it's common sense, even though you don't need to be in a lab, that you can use a ruler, for example, to measure length. And here it says that the smallest marks represent in our example 0.1. Let me show you. You are going to use this ruler to measure the length of this block. How are you going to measure? What is the first thing you need to do? You always have to look at the two closest lines, what length it represents. In our case, it represents 0.1. I want to make sure that is clear. Everybody sees that. Let me make it bigger. that each closest line, so we have here, we are measuring centimeters, so we are using the lowest scale. So we know we have a 15 and we have a 16. But we have to look at the smallest markings. Here is 15.5, right? 15.5. And 1, 2, 3, 4, 5. So we look at the smallest marking and we know it represents, it says 16. Okay, so 16 is, oh yeah, you're right. What you are saying is that here is 16. Thank you. Okay. Yeah. Here is 16. Thank you. Thank you. Awesome. Awesome. So you're right. So when we have to decide how are we going to report a measurement, we are using this ruler and we have to measure this rectangle. First thing we do, we look at the closest markings, and we look here at this closest marking between two lines that I cannot see that well in here, and the closest marking represent 0.1 centimeter. And we know that our value, when we look at here, if we can make, our value is between 15.2 and 15.3. This is what we know because we looked at the smallest marking, and this is for sure. And what we said at the beginning is that we have, what did we say? We need to record all the digits using the markings plus one digit, and that is the estimated digit. So we have to estimate. Well, we can estimate that we have to use one more decimal, and here we have to estimate the hundredth digit. So we will say, okay, our value is this length is 15.25 centimeters. We estimated the last digit, that is the 5. And because the last digit is the one that has the error and the uncertainty, we accept that it can be 15.24 or 25. We have to look how close, if it's closer to the higher marking or the closest or the lower marking, but that still is the last digit has the uncertainty. Any questions? Okay, you're welcome. So now we are going to continue. We know how to measure length. One thing that they are talking, they want us to make sure that when we report any measurement, it's not like math. If we start from the beginning, this is 1411, and we start getting the correct habits, it will help us along the way, not only with other chemistry, in work, you never know if you're working in a lab. So what they are reminding us is that when we do a measurement, we have to record the numerical value and the units. So if I ask you what is the length of that rectangle, you will have to say, well, it's 15.25, but it's not math. You have to add centimeters, because has no value if I ask you, what is the weight of your pet? And you tell me 60. It has no value. I don't know if it's 60 pounds or if it's 60 kilograms. So that's why it's important to get the habit of writing the number and the units. And also, as you progress, you will need to write the units to make sure when you do conversion factors and they cancel out, you have the correct units and the correct answer. So now we said, okay, we know how to measure length, and here they're talking about measuring volumes. You can measure volumes. We will use 3 different devices to measure volumes. They use a beaker, a graduated cylinder, and a burette. Those 3 are different pieces of glassware that have different objectives. A beaker, when you measure the volume with a beaker, the volume is not going to be that accurate. It's basically the idea of a beaker is to hold temporarily an amount of liquid, but the scale, let me see if there is a drawing of all the no, not here. Okay, that's okay. So we said a burette, we are going to have a beaker, but the beaker is something like that. So you will have some markings. Maybe we'll say 100, and maybe here 200. So you will have an approximate idea of the volume of the liquid inside, but it won't measure an accurate value. And then we are using here, this is a graduated cylinder. This is a graduated cylinder. If you see the graduated cylinder, the scale starts at the bottom. So here is the 0, and it increases the number as you go up. Here you have 100 mLs. So when you want to measure the volume of a liquid using a graduated cylinder, like this one, you have to do the same as what we just seen with the ruler. You have to look at the smallest size markings, and in this case, represents 1 milliliter. This is the first thing you have to do. Otherwise, you won't be able to report correctly with the correct amount of sig figs the volume. So the first thing, okay, I will look what is the smallest size marking. And we know it's 1 ml because we look at 60. This is 60. This is 70 here. This is 60. In the middle is 65. So, and there are 5 lines, markings in between. So each line 60, 61, 62. So the difference between 60 and 61 obviously is 1 ml. So the smallest marking is 1 ml. And when we look at the volume here, we know that our value, again, is in between 66 and 67. Because we know that one small marking is 1 ml. And now we said that we have to go for one more. We have to estimate one digit. And then, in order to estimate, we look, is it closer to the 66 or closer to the 67? In this case, it's closer to the 66. So our value is, for them, 66.2 mLs. So the same thing as we did with the ruler, we do with the graduated cylinder. Any questions? Okay. So now we know that the last digit estimated has the error. And here it says that if somebody sees that is 66.1 or 66.3, it's also acceptable. We know that that number has the uncertainty. Yes, Karen.
Okay, thank you. That's the part that throws me off. I'm sorry, I don't know if you've explained this, but we said it was acceptable to do 66.2, but when you said that the last part is the one that has the error, you're talking about the 2, right? The 0.2?
Exactly. I'm talking that because the last digit is not that we know for sure. It's our eye that is looking. So if I look, I see this, I'm talking about the last digit.
Okay.
The other cannot have an error. The other, see, the other 66 is always going to be there. 66 dot something. But the last digit, because when I look, I wear glasses, maybe I don't see that well, and I think it's a 66.2. I have to kind of mentally divide that milliliter, that small marking, into 10. And I have to do it kind of, it's abstract. I don't have a scale. So I kind of divide it and I'm saying, 0.2. But somebody can say 0.3. And even though if you say 0.5, it's okay. Nobody's going to say, because if you say 66.9, well, that might be that you are seeing that the liquid is closer to the 67.
Okay, and so basically the 0.2 is what we are referring to having the most margin of error, I guess?
Exactly. The number 2, which is the last digit of the number, is the one that has the error.
Okay.
The uncertainty. That's why. Yes, exactly. But what you have to know is that you can only guess one and stop there. So if you are using this graduated cylinder, the way to report is only 1 decimal after the dot. So if I ask you how to report this number and you tell me, well, 66.25, that will be incorrect. Does it make sense?
Okay, so that only applies to, for example, the ruler. How in the ruler we said 15.25, but because this is liquid.
Right, and it's not only the ruler, depending on the scale. So depending on the scale that you are using. So let's say I have a ruler that has a number 10 and a number 20 centimeters, right? A different ruler, and I don't have more markings. It goes by 10 by 10. And then, okay, I have something that ends here. I know that my value is between 10 and 20, right?
Yes.
And I have to guess, but I know that in between these two numbers, it's only 10. So I will say, well, here might be the half. It's a little less than half. So I would say that my value is 14 centimeters. I cannot add a decimal because I don't have more markings.
Oh,
And the 4 is the one I guess.
okay, that makes sense.
So if you are using an instrument that has more markings, then you can guess one more and you will have more decimals. And we actually will go over that. This is, but then if I use an instrument like has, like we did before, I always do this X that at the beginning, and I said, what do I know? I look at the smallest marking. Between the two markings, there are 10 centimeters. So I have to guess if it's 11, and does it make sense?
Yes, it does. It just clicked.
Okay, great. And we are also going to practice more, and I will stay at the end. And this is important to carry out in the whole semester, and even if you do CHEM 2. So I will stay to make sure that I answer all the questions. So
Okay.
then oh, awesome. So then is talking about how to measure this using, so one important thing is reporting the right amount of decimals or the sig figs. We can only guess one and stop there. That's why our correct way is 66.2. But another thing that we have to be careful is where, of course, we are doing this experiment virtual, but you need to learn that if you are in a lab and you are measuring that volume, you add the liquid inside that graduated cylinder, and you have to place your eyes at the level of the liquid. If you look from down, let's say you put your eyes right here, you are going to read maybe a higher value. And if you look from upper, you are going, because of the way the eyes look, you are going probably to read a lower value. So it's important that your eye, as it says here, is at the level of the liquid. So that's one consideration and to learn. And the second consideration is that when you put a liquid inside the graduated cylinder, what happens is that there is interaction between the liquid and the glassware. So the liquid, instead of being just straight, makes a little interaction with the walls of the cylinder, and this is called meniscus. So if you are in the lab and you said, oh, I have to read a correct volume, where do I look? Do I look in the upper part or do I look in the lowest part of the meniscus? The answer is the lowest part of the meniscus. So you are going to do an imaginary line here and read the lowest part of the meniscus. So this is another consideration that you will need to remember when you are using this type of glassware. And then reading the meniscus at eye level. And another way of measuring volume here is using a burette. So what is this? A burette. So we saw a graduated cylinder, we saw a burette, we saw a beaker. And what is a burette? In the graduated cylinder here, the zero is down and increases as you go up. Here is the opposite. The zero is up and increases as you go down in the burette. So the markings on a burette starts with 0 on the top and increase as you go down. And then let's look at if we measure with a burette, is it going to be more accurate than a graduated cylinder or less accurate? Well, if we can report our measurement with higher amount of sig figs, our measurement is more accurate. So we said that with the graduated cylinder, we have 1 decimal. We have to report, because the way the markings are, because each smallest marking was 1 ml, we have to report with 1 decimal, 66.2. Let's look at the burette. The burette, it says here that the smallest marking on the burette represent 1/10 of a milliliter. It's even less, because I don't know if you can see, but let's make it a little bigger. So here, let's say it says 19, the scale. And then we said that increases as we go down. We have the 20 here, 20 mLs. But this is just, also it has 1, 2, 3, 4, 5, 6, 7, 8, well, 9, 10, another, whatever. So each small marking represents 1/10 of a milliliter, 0.1 ml. So when I look at a value, I will say, okay, if I have the value here, I can say, well, look at the small mark. I can count, because the scale is there. I can count and say, well, 1, 2, 3, 4, 5, 6. I can say, for example, that my value is between 19.6, just to give you an example, and 19.7 milliliters. And this is not guessing, it's what I know, because I look at the smallest marking and I said that the smallest marking represents 1/10 of a milliliter. And then all measurements using this burette, it says here, need to be recorded to the nearest 100th of a milliliter. So that means the correct way of reporting, for example, can be depending 19.63 mLs. So I have 2 digits after the decimal with the burette, but with the graduated cylinder, I had only 1. So which one do you think is more accurate? The burette? Yes, exactly. Very good. Exactly. So these are the 3 different instruments to measure volume. And we always have to remember, here they remind us that we have to put our reading, our eyes should be at the same level as the liquid. And here it says, if you read at the bottom of the meniscus. So if we read from above, here the eye is above, we get a lower number. And if we read from lower, we get a higher reading, what we just said before. So we have to make sure that we put our eyes in the correct level. And then what else is talking in this experiment? Okay, so now we know how to measure volumes, And here they are telling that volumes, if I have to read a volume, of course, I can just pour the liquid and look at the scale and report the volume. But sometimes you have a solid, like has a, I don't know, like a little shape like that, different shape, and it's any shapes. And let's say this is a metal. And you want to know the volume of that metal with that weird shape. What do? One way of measuring the volume of a solid is placing some liquid in the graduated cylinder. So here they are showing you put some liquid and you read the initial water level. Then you add this, whatever you have, you add it. And you read the final volume. You are interested in the volume of the metal. So the difference between the volume of the object is the difference between the final water level and the initial water level. Does it make sense? Awesome. So now we saw measuring volumes, and now we want to know how to measure masses. Well, there is a video that you are going to look in Lab Flow that talks a little bit about balances. Because it's a digital instrument, you don't have to guess. What's important is that you have to write all the digits. You place whatever. First, obviously, you have to make sure that the balance is 0 before you put everything. So what it's saying here is important to make sure that the scale reads 0, but that's common sense. When we are going to weigh ourselves, we put the balance of 0, and then we put ourselves on the balance, and then we read. This is a digital balance, so there is not much to learn here, how to read a scale, because it's a digital instrument. What it's talking about is zeroing the balance is called tearing the instrument. So sometimes you want to measure the weight of a liquid. So what do? First, you have a beaker, and you zero the balance, and you have two ways of doing it. Either you weigh the empty beaker, and then you add the, okay, this is the empty beaker. Sorry, let me erase everything. So you have two ways. Either, if you want to know the mass of a liquid, either you measure the empty beaker, and then you measure the weight of the beaker with the water, and you subtract one from the other, or you place the beaker, the empty beaker, on the balance. Then you tear the balance after you place the empty beaker. So it's 0, you see a 0, and then you add the liquid. So in the balance, you are going to see the weight of the sample or of the liquid because you zeroed it out. But I believe this is just common sense. And then what comes next in this experiment is to do calculations. Once you have your measurements written correctly, depending on which instrument you use, if you use a burette with the correct amount of sig figs, you need to learn to do calculations and express your answers with the correct amount of sig figs. So it will be different if your calculation is adding or subtracting, or if it is multiplying or dividing. So here they are showing that some examples in the experiment. So here it says, if we are adding and subtracting, the measurement must end in the same digit as the measurement with the fewest number of digits to the right of the decimal point. This is if we are adding. So they are giving us some example. We are adding 10.0 centimeters plus 5.46 centimeters plus 12 centimeters. So when we have that, first thing we do, we look, are they all centimeters? Yes. Okay, so then I can use my calculator. Then you use your calculator and you obtain, the calculator will give you this number, but this is not the correct number because here you have one digit after the decimal. Here you have 2 and here you have 0. So your answer cannot have any digit after the decimal. The correct way of expressing your answer when you do calculation is 27. And so when you are adding or subtracting, you basically look at the number of decimals. But when you are multiplying or dividing, you have to look at the number of sig figs. So here it says, for multiplication and division, the result of a calculation involving measurements has the same number of sig figs as the measurement with the fewest number of sig figs. So basically, they are giving us an example. They are dividing this number by this number. What do I need to do? The calculator is giving me always a lot of digits. So I count. The denominator has 3. The numerator has 1, 2, 3, 4, 5. So my answer has to have the lowest, only 3. So I will say 1, 2, 3, and I'm going to draw a line. And then I look at the next number. The next number is a 3, so I have to leave it as it is. But if the following number is a 5, I have to round up. Any questions in there, how to calculate and multiply and divide?
No, I'm clear on that. I am going to ask you afterwards more questions about significant digits or figures.
Yes.
I'm struggling with those a lot.
Sure, absolutely. Happy to do it.
Thank you.
You're welcome. So here, then, they're giving you, so basically it's all about measurement and doing calculations. So all the report here is about measuring, they are giving, and then these are formulas to do calculations. And you are going to calculate the density of an object. And the density, you know, is mass divided by volume. So you're going to measure the mass, you're going to measure the volume, and calculate the density. And here they are explaining all the different, there are 5 different parts of the experiment. So we can go quickly over, and then we'll go over the report. But just to look at what is involved, what are we going to do in the report? So here, the part A, basically, all you have to do is measure the length and the width of a rectangle. And obviously, it's going to be given because you are not going to the lab. So all that data is going to be given. So all you have to do is basically calculate the area of that rectangle and express it with the correct number of sig figs. Then in the part B, instead of measuring the surface, or you are going to calculate the volume, and they're going to give you, okay, the dimensions. Maybe you have a cube, and they will give you the width, the height, the length. They will give you, if you have any form, and you will have to calculate the volume of your block. In part C, you are learning how to weight on a scale by difference. So all is what we just seen. Basically, here it says you zero the balance, and then it says place a beaker on the balance and record the mass on the digital scale. So you basically will have an empty beaker, and you have the mass of the empty beaker. And then it says put some sugar inside the beaker, and you're going to have the mass of the beaker plus the sugar. And they will ask you, what is the mass of the sugar? It's obviously that you're going to subtract this mass minus the mass of the empty beaker. So this is part C. And then part D, we are measuring volumes directly. So basically, we are using 3 measuring devices: a beaker, a graduated cylinder, and a burette. And we went over that, and also I will go over the report to make sure that we are all ready to complete the report. And then the last part, no, it's not the last part, the calculating the density of the water. So what do we need? We know that density is mass divided by volume. So first, we want to know the mass of the water, and we weight by difference. It says measure the mass of a clean, dry 100 ml graduated cylinder, and then we add the water and we weight again, and the difference is the mass of water. And this is called by difference method. It says calculate the mass of water inside the graduated cylinder by difference methods. So we know the empty, we have to subtract the mass of the empty graduated cylinder in order to know the mass of the water. So we have the mass of the water, and then we record the volume, and we calculate the density. And then the last part, we calculate the density of aluminum and the thickness of the foil. At the density of the aluminum, the volume of the aluminum, we are going to calculate it the way I explained before, that we add the solid inside the water, and by the difference, we know the volume of the aluminum. Remember that? So we have a graduated cylinder with water, and we add the solid, and the volume of the solid is going to be the volume final minus the volume, the initial volume. So the density of the aluminum, it will be the mass divided by this volume. And then there is a formula to calculate the thickness of the foil. And this is basically an overview of, it has like 6 parts or 5 parts, these experiments, but it's all, as I said at the beginning, measuring, but you are not going to measure. So for you, it will be only calculating with the correct amount of sig figs. And before I go to the report, I will go over some practice problems, and I would like to take this opportunity if you want to ask me some questions.
Well, yes, I don't know if you want to wait on these questions, but it was about the significant digits or significant.
Okay, okay. So then we'll do it at the end. We'll finish this experiment. Okay. Okay. So about the what I was explaining, it seems that it's clear so far.
Yes, ma'am.
Awesome. Thank you. Okay. So let's try to do this one. And let's see, because this is similar of what you will have to do in the report. So let's read it. It says, calculate the area of a rectangle in square centimeters with a width of 7.6 centimeters and a height of 3.3. Let's see if you can do it on your end and tell me the answer. That will be a good practice.
Yes.
Or you can write if you want, but as you wish.
Okay, that's just the area of the rectangle.
Right.
And that is length times width.
Exactly.
$25.8 centimeters.
25 point what?
8 centimeters.
That's what you got?
Yes.
Okay, let me see. Because
0.08. I'm sorry, 0.
okay. Now makes sense. Awesome. Okay, so what are the units?
Centimeters.
Because you are multiplying centimeters.
Square.
Exactly. Awesome. Square. Awesome. So now the calculator gives you all this. But you multiply, right? You said the area equals the height, whatever, times the width or whatever. So because you are multiplying, you have to look at the sig figs of each number. How many sig figs has 7.6?
2.
2. How many sig figs has 3.3?
2.
2. So our answer cannot have more sig figs than 2.
Okay.
So how are we going to report the area?
I want to say we're just 25 centimeters.
Yes, great, awesome, perfect. Okay, so are the little things that we have to look at. Very good. Let's look at the next one. How do you determine the last digit in any measured number? We talked about this. We said that the last digit of any measured number is the estimated digit.
Yes.
We have to measure, exactly. We have to measure all digits that we know with certainty, when we know all digits by reading the smallest markings on a volume or length scale. plus one estimated digit. We know that, but we just want to make sure. Awesome. Okay, now let's see if you can tell me what is the correct way to report the length of the rectangle in centimeters. If I'm using this ruler, it's measuring in centimeters. So the first thing I have to do, look at the smallest marking. And I will say this is a 1, this is a 2. What is the small? How many are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? So between two markings, what it represents? It represents 0.1 centimeter, right? This is what I know, because this is 1.1 here, 1.2, 1.3, 1.4, 1.5, 1.6. So my value is between 1.6 and 1.7, right?
Yeah.
This is what I know. So how are we going to express? If I said, tell me if I'm using this ruler, give me the length of that block with the correct amount of sig figs. What are you going to say?
1.7 centimeters.
1.7, it would be if it's exactly here.
Okay, so it would be 1.6 if it's not exactly there.
And it will be 1.6 if it's exactly there. But even though if it's exactly in 1.7, I would say 1.70, because remember that I have to guess. I know up to the 0.1, one digit after the decimal, but I have to guess one more. So my correct amount of sig figs have to have 4 digits after the decimal. So that's why, even though if this ends exactly in 1.7, I have to say 1.7 centimeters. But in our case, it's kind of in between this and this, but closer to 1.7. So I would, yeah.
1.65.
Exactly. Or it's a little bit closer to the 7, right? It's not exactly in the middle. So I would say 1.67.
Okay, that.
So maybe I'm messing everything up. So let me erase to make sure that so the first thing we do is look at the smallest marking and see that this it's a little closer to this number, and this number is 1.7. And this number is 1.6. Because I go 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. And this ends between 1.6 and 1.7. And with just one digit after the decimal, I'm not guessing. I have to guess one, and that will be the right amount of sig figs. And that's why I have to express my value like 1.67 centimeters. But if you see 1.66 is correct also. But this number, the 7, the last digit, is the estimated value. It has the uncertainty, and we stop there.
Okay.
And then we go, let's do another practice here. This is similar. How would you express the correct volume of this graduate cylinder?
17.6.
Perfect. Awesome. 17.6. Exactly. Because each marking is 1. So our value is between 17 and 18. And I have to estimate one more after the dot, the 6. Awesome. Then let's see. It says, okay, if you have to calculate the volume in cubic centimeters of a box, which is this long, this wide, and this high. Okay, let's see what you get.
And for the volume, it would just be multiplying all of them, correct?
Right.
Okay.
Yeah, you can tell me the value of the calculator, and then how are you going to express that value?
So I got this.
Okay, so the calculator tells you 314,500. And the units, because we are multiplying 3 times centimeters, are cubic centimeters.
Yes.
Very good. Now we have to look how many sig figs we need to include in the volume. How many sig figs has the first number? 125. How many sig figs do you see?
3.
3. How many sig figs in 37?
2.
2. And how many sig figs in 68?
2.
Very good. So what is the number of sig figs that the volume has to have?
2.
2. Very good. 2. And we have to we count 1, 2, and we make a little line here. Because we can only express our answer with 2. But because we cannot erase the value of the number, we have to add zeros to keep the place value of the number. So because this is a 4, we don't have to round up. So we are going to keep, instead of each number, we are going to add 4 zeros. 1, 2, 3, 4 cubic centimeters. And that will be the answer. Does it make sense?
Yes.
Okay. Because some students just say, okay, 2 sig figs, the volume is 31. Obviously, cannot be. If somebody owes you $300 and you need 1 sig figs, it's not the same as $300. You have to keep the place values, right, of the number. So very good. So this is the way we express with 2 sig figs and the rest zeros. Very good. And the last question, just for practice, it says, what is the clear 0 button on the balance? It allows, yeah.
It's to zero it out.
Exactly, exactly. So that's all it is. It allows you to zero out the balance with something on it. You can, so exactly. So you have a bigger, you tear the balance, and then when you add the mass, only the mass of the sample appears on the balance. So that makes sense. And I think, let me see if there is another practice here. Let me see. Okay. I don't know why it came in violet. Okay, so let's do the last practice problem. A graduated cylinder contains 10 mL of water, and you add a piece of aluminum to the water, and they give you the final volume, and they ask you what is the density of the aluminum. So what is the first thing we have to do?
We're going to subtract.
Yes, what do we need to subtract?
15.46 minus 10.
Exactly.
So that would be 5.46 ml.
5.46 mL. And that is the volume of what?
That's the displacement, I guess, of the aluminum.
Right.
Of the water.
And that, exactly. And that, the displacement of the water is exactly as the volume of the aluminum.
Yes.
It will show you the volume of the aluminum. And they ask you for the density of the aluminum. And the density is the mass divided by volume. The mass of the aluminum divided by the volume.
Mm-hmm.
The mass they are giving us, 14.74 grams, divided by 5.46. What number did you get?
Oh, let me answer that.
Okay.
So 14.74 divided by 5. Okay.
Yeah.
I got, here, I'm going to type it, 2.69963337.
2.69963. Very good. And now, if we submit it that way, it's going to be wrong. We have to submit it with the correct amount of sig figs. So how many sig figs do we need to report, or we need in our density?
Let me see. So for multiplication or division, we need to do the fewest number of significant figures.
Very good.
So it would be 3.
Exactly. So then it's 1, 2, 3. We make a little line here, and we look if we have to round up or down. Do we need to round up or down?
Up.
Up. So we are going to say that our density is 2.70 grams per ml. And that will be the correct number of sig figs, because the calculator will give you so many. So we need to be careful with that. Yes. I guess with practice, for now, we are good. And I would like to go back to the last part of the report to make sure that you will know what to do when you get there. This will help you, I think, with the quiz, all this practice.
Yes.
Let me see. We saw that, and we got up to here. Okay, here they are explaining, they are showing us here some examples of how they will do the report. So basically, you can read it, they are solved, they're saying, okay, they will give you the base of this triangle and the height, and they basically show you how to do it. They say, okay, calculate. In this case, you won't have to do it, but these are just examples. They want to know the length of the triangle. So they says you will receive no credit for any calculated value unless the work is shown here. So how do they calculate the length of the side? You know that this number square, x square, this is math actually, we don't, plus y square is going to be a square. So basically this length they calculated by doing this, using that formula. And they will show you what they do and how they calculate the sig figs. But these are just examples, how they did. You can look at them when they add. Here they are saying they add all measurements end in the hundreds digit because they are adding here. So the answer needs to end in the hundreds digits, 2 digits after the dot. But this one you can read is simple. And then we end here. This is the part A. This is what you will have to do in your report. It will look a little different probably, but it's the same thing. But what is happening is that because you are not in the lab, you are going to be given the length, and you are going to be given, let's say, the width. These are numbers that you are going to be given. They're going to come in red when you go to the maybe I will show you. Okay, let's do this and then I'll show you how it will look, and I will share my page. So the area of the rectangle is going to be the same as what we just did. So does it make sense? Stop me if I'm assuming that this
It does. It makes sense, especially if they're going to give it to us.
Exactly.
Yeah.
They will give it to you. So so basically, let's say, just to give you an example, they will say it will be in red, 8.78 centimeters. Just to give you an example. And then the width will say, okay, 3.16 centimeter. And you will have to calculate the area, and it will be the show, and you will have to show the work. So you will say, okay, the area is going to be, obviously write the units, write everything, 8.78 centimeters times 3.10 centimeters, and let's say I get a number of 27.7 square centimeters. And then I have to look at the sig figs. Here there are 3 sig figs. Here there are 3 sig figs. So my answer can have 3 sig figs. So I will report here 27.7 square centimeter. I wanted to tell you that if you see a square, don't write the units because it's going to count wrong. If it says here in the report centimeter, don't write it again, just the number. That is a problem of lab flow, just the number. So the area is, so part A is easy. And then same thing, you will have to calculate the circumference, but you have the formula of the circumference. So you will, is basically, if you have a rectangle, and this is A, and this is B, you will have to calculate 2A plus 2B is going to be 2 times A plus 2B is the circumference. And they will give you the, basically they will give you the formula as well. So this is all about calculations and sig figs. That's all. Area of the circle, circumference of the circle, and then part B, it will be measuring length of volume. So then you go into volume. Again, they will give you all the length, the height, and the width of the rectangle. So all you have to do is calculate the volume, multiply, and make sure you express your value with sig figs. Any questions so far on what do you have to do in your report?
No, that seems pretty clear.
Okay, and then part C, it says weighting on a scale by difference, and this is what we just saw. They will give you the mass of the beaker, and they will give you the mass of the beaker and the sugar. So all you have to do is subtract basically one from the other. And where it says show work, let me see, you will write it here to make sure that they know. Maybe it will be a little difference, but it's all about the same. Sig figs and calculating, and then measuring volumes directly. So they will give you basically they will give you all this information. This is something they will tell you. And here, for the mass, again, mass of 100 ml, the empty, mass of the cylinder plus water. So if you want to know the mass of the water, you just subtract one from the other. This is all it is. The volume of the water, they will tell you. And the density you will calculate by mass divided by volume. But make sure you pay attention to the correct number of sig figs. The last part is density of aluminum and thickness of the foil. So basically, the density of the aluminum is what we've been seeing all the time. Density, we said, is mass divided by volume. So they give us the mass of the beaker and the mass of the beaker plus the aluminum. So by difference, this minus this, we calculate the mass of aluminum pellet. And that goes here. And then the volume, how do we calculate the volume of the pellets? The same way as we saw by difference. This they will give you the volume of the water in the graduated cylinder, the volume of the water plus the pellets, and by difference, we are going to calculate the volume of the pellets. And then once we have the mass and we have the volume, we can calculate the density. Okay, so here we are going to show this here, and we are going to show this here. And the density, we are going to show it right here. We have all the values, mass divided by volume. And the last part of the experiment, once you calculate the density, they want you to calculate, they will give you a foil of aluminum. But you already calculated in the previous section the density of the aluminum, that is mass divided by volume. And then they will give you a foil, and they will give you the length and the width and the mass. So what you will have to do, the volume of the aluminum foil, you know the density and you know the mass, so you will use this formula. So from here, the volume of the foil is going to be mass divided by density. Does it make sense what I did? I basically multiplied both sides by volume and divided by density. Do you see how I went from this formula to this?
Yes.
Okay. So then they will give you the mass. You put it here. The density you already calculated. So you are going to express the volume of the aluminum foil. And you're going to show the work here. But then, what is volume? Volume is the length times the height times the thickness. I can say thickness. This is what you have to kind of calculate. But you have the volume, you have this value, and you have this value. So what they are asking you is the thickness of the foil is going to be the volume that you calculated divided by the length and the height or the width, whatever you want to call it. Does it make sense?
It does.
Okay. So this is all basically that what's included in the first experiment, and it's about making sure, as I said, that you include the correct number of sig figs. So what I will do right now is stop the recording, and thank you for being here, and I'll stay so I can answer the other questions that you have.
Yes.
Thank you.